Yes. Hello, welcome you all for one more session on vibrations. So in my last lecture I just introduced you and told you what is meant by vibrations. So vibrations, we said that it is a repetitive motion, it is to and fro motion, a motion which keeps on repeating. That means any repetitive motion can be of two types, periodic motion and non-periodic or periodic motion. A motion which repeats after a fixed interval of time, and that is called as a periodic motion. Okay. So in our discussion we are going to have only periodic motion in our brief introductory understanding of vibrations in this course. And every vibration deals with something what is called as a cycle. Okay, so in vibration we have something called as extreme positions, and there is something what is called as mean position, the midpoint of those extreme positions. And if you start journey from any one extreme position and go to the other extreme position and then come back, this journey we call it as a cycle. And every cycle is considered equivalent to completing one cycle like that, and it is 2 pi radians. So it doesn't mean that we really go one complete circle around, not like that. In vibrations, even if it is an angular this thing, say something like this, going here, one extreme position, and then going to the other extreme position, and then coming back. This is what we call it as one cycle. Okay. So if you have vibrations along a straight line, for example, spring mass system as I said, okay, so this is one extreme position and coming down and then going back. This completes one cycle. So one cycle doesn't mean that we need to have one complete rotation, not necessary. Okay. So we say that one cycle is completed and that is equivalent to in mathematical analysis, and one cycle is considered as 2 pi radians. Then we have time period. All these terms I yesterday defined, and then since we require them every now and then I keep on repeating. So time period is the time required for one cycle. So how much time is required for one cycle, that is called as time period, and normally I denote it by T, capital T. Okay? So usually it is in terms of seconds. Okay, frequency. Then how many cycles do we have in one second? In 1 second, not in one time period. In one time period I can have only one cycle. So in 1 second, how many cycles can I have it? Okay. So how many repetitive motions, how many cycles do I have in 1 second unit time? Okay. That is called as a frequency. And I have used two notations here. One for small f, the other one is omega. F and omega, these are the normal notations used for frequency. So frequency, as I said, number of cycles per second. So this is what I call it F. I shall use this. Okay, number of cycles per second. The same thing I can express it in radians per second also. Okay, as so one cycle corresponds to how many? So number of cycles per second. If I have, then I denote it by F. Say I have F cycles per second, and one cycle per second is also has a separate name. Okay, that is called as hertz. So hertz means cycle per second, and this is also called as okay, I can call this as F hertz. F hertz is equal to F is a number. F is a number, and that is a frequency which has been expressed in terms of hertz. Okay, so F cycles per second. The same thing. 1 hertz is 1 cycle per second, F cycles per second. And the same thing, but if I want to express omega is also the unit of frequency or the notation for frequency whenever you express it in terms of radians per second. If I express the frequency in radians per second, then I use the notation omega. Okay, what is the relationship between omega and F? Omega and F, for example, this F cycles, F is a number, F cycles per second. One cycle is how many? One cycle is how many radians? As I said, one cycle corresponds to 2 pi radians. This is nothing but 2 pi the cycle is 2 pi radians per second as usual. I am not changing it. So this is nothing but 2 pi f radians per second. And what is radians per second? That is nothing but omega. So therefore, what is the relationship between omega and f? Omega is equal to 2 pi f. Omega is equal to 2 pi f. And similarly, what is the relationship between f and t? F versus t. What is the relationship? What is f? Number of cycles per second. Number of cycles. How many cycles does it take? Okay, to have. Okay, if I can have f cycles in 1 second. F cycles in 1 second. What is the time required for 1 cycle? I can have f cycles in 1 second. And what is the time required for 1 second? 1 cycle. Okay, what is f cycles 1 second? 1 cycle, how much time? That is nothing but 1 by f. Okay, I can have f cycles in 1 second. So how many? What is the time required for 1 cycle? That is nothing but 1 divided by f. Okay, what is the time required for 1 cycle? This is nothing but the time period. So therefore, the time period t is equal to 1 by f, or f is equal to 1 by t, or in other words, t multiplied by f is 1. Another way. So you may have any of this combination. This, the frequency expressed in hertz and the time period in seconds, they are reciprocal to each other. And this also sometimes when we solve problems, that is going to be useful. Then I have something what is called as amplitude. Amplitude is nothing but the maximum displacement from the mean position. The maximum displacement from the mean position on any one side is called as the amplitude. Remember, amplitude is never negative. Amplitude is always positive, though you measure the displacement on the negative side. I hope you understand what I mean by that. So let me take the example of what is called as the simple pendulum. Okay, this is what we call it as right now, whatever has been shown, that is the mean position, and say when it is vibrating, and say, let me assume that this is one extreme position, and say this is what other extreme position. If I measure the displacement, if the pendulum is on any one side, say I shall measure this, I shall take as the reference. And what is the displacement here? And any angle made with respect to this. This is the position of the pendulum right now at some instant. What is the displacement? I shall call it as theta. Okay, so what is this? This is nothing but theta maximum. Okay, so theta maximum, this side also is same angle, theta maximum. So therefore this theta is nothing but the displacement. Displacement from where? From mean position on any one side. So what is that displacement? That displacement is maximum. The maximum displacement from any the maximum displacement on any one side of the mean position, that is called as amplitude. Amplitude is never negative, it is always positive only. Okay, so if you have angular displacement, the amplitude is in terms of the angle, which may be in degrees or radians. And if you are talking about the linear vibrations like spring mass system, in that case the amplitude is going to be so many millimeters, something like that. Okay, then what do you mean by degree of freedom? Degree of freedom, and you have come across this term degree of freedom in many subjects, especially the kinematics of materials, and now also. And so what is degree of freedom? Degree of freedom is basically the minimum number of independent coordinates. Minimum number of independent coordinates required to specify the position of a system. So if the system is static all the time, then you don't require any degree, any variables, therefore its degree of freedom is 0. So I have the system which is dynamic, which is moving. Okay, so it is occupying different position, and in that case, what is the position? Where is the system? So at any time I should be able to tell. For that, how many minimum number of independent coordinates required and all that. That is called as degree of freedom. I repeat, minimum number of independent coordinates required to specify the position of a system at any time, okay, is known as degree of freedom, okay, of that system. So now, right now I don't spend much time on this, and I hope this is what is required, and for your examination point of view, from the definition point of view. Otherwise, if you are there in front of me, I would have posed hundreds of questions and discussed this degree of freedom for length, hours together. Okay. Unfortunately, you are not there, and fortunately for me, I am able to save the time. Okay. If you still have, why I spend so much time is each word is important there. Minimum number of. Why minimum? If it is not minimum, then how does it affect? Minimum number of independent coordinates. What do you mean by independent? Independent coordinates. Okay, all those terms are very, very important. That's why I used to highlight and give example. I hope you will be able to appreciate and understand the importance of each and every term there, and the meaning of degree of freedom. What is the degree of freedom? The minimum number of, if any one term is missing when you write the definition of this, I don't give any mark. Okay, if you say minimum number, minimum is missing. If you say number of independent coordinates required to specify the position, all that, everything fine. If that minimum is missing, I give 0, whatever the marks are. Okay, so therefore minimum number of independent, both of terms must be there in your definition, otherwise your definition becomes null and void, meaningless. Then I have added, all these terms were there yesterday also, and this is what I have added something now. So what is called as SHM, probably not new. Okay, in your kinematics of machines while drawing the cam profile. Okay, the follower, reciprocating follower is undergoing a motion, simple harmonic motion. So, simple harmonic motion, maybe in your school days, high school days, PUC, definitely you all have studied. Okay, I would like to come back and spend some time on this. I don't say I am teaching it, I am revising whatever you have learned about the simple harmonic motion. What is simple harmonic motion? As it says, M stands for motion. So it is also a motion. Okay, and it is a repetitive motion. This is a repetitive motion. Therefore, any motion which is undergoing simple harmonic, definitely I can say that it is undergoing vibration. So therefore, this for vibration study, this is a very, very must. So anyone who starts studying vibrations, he will spend lot of time on simple harmonic motion. And for our requirement, I am not going to spend so much time. Okay, otherwise I would have spent about 5-6 hours on simple harmonic motion. Probably I shall spend about 15 minutes, 20 minutes, or at the most half an hour on simple harmonic motion now. Okay, so it is a repetitive motion. Okay, it is a to and fro motion. Okay, it may be a motion, any particle body which may be moving along a straight line, that also may have simple harmonic motion, like the reciprocating follower in case of a cam and follower mechanism. The reciprocating follower is moving along a straight line, and that is undergoing simple harmonic motion. Okay, it may be the angular motion, the pendulum, simple pendulum which I had shown, and that may be undergoing simple harmonic motion. Okay, so okay, now with that, simple harmonic motion is a to and fro motion, it is vibrations. Okay, it is a repetitive motion, it is going to repeat after a fixed interval of time, it is a periodic motion. So everything is fine. Okay, then what is simple harmonic motion? How do you define it? So this motion has a very peculiar this thing. So as I said, motion, displacement, how do you describe motion? using the parameters, three parameters. What are those? Displacement, velocity, acceleration. Displacement, velocity, acceleration. These are the three parameters normally used to describe any motion. So similarly here also, this also is a motion. I shall pick two parameters. One is displacement, the other one is motion. Other one is acceleration. Displacement and acceleration. These displacement and acceleration of simple harmonic motion, they are related to each other. So what is the relationship? They are directly proportional. Displacement is directly proportional to the acceleration. Okay, a motion whose displacement is directly proportional to the acceleration. Very peculiar thing. Okay, so normally x is the displacement. Then I have one more. What is the acceleration? What is the notation? I shall use it for x double dot. X and x double dot. So x is or x double dot whose acceleration is directly proportional to displacement. Why acceleration? Because acceleration comes later on. First you have displacement and then velocity and then acceleration. So a motion whose acceleration is directly proportional to the displacement. Okay, it is only one part. Okay, this is one part, this acceleration, and is always towards the mean position. The direction of the acceleration is always towards the mean position. That completes the definition of simple harmonic motion. Say, what is simple harmonic motion? Simple harmonic motion is a to and fro motion whose acceleration is directly proportional to the displacement and the acceleration is always towards the mean position. Okay, very important. So now, alright, the definition, probably this definition will not give you much unless we go for some mathematical listing. Okay, this is one definition. Whatever I have said now. Okay, so what is that? The acceleration directly proportional to the displacement and always towards the mean position. This is one definition. Okay, there is another definition of simple harmonic motion. What is that? Simple harmonic motion. Okay, imagine that there is a particle which is moving along the circumference of a circle whose radius is equal to, say, A. A is the radius of a circle. Okay, so you have a circle. You have a circle and say this is the point, this is the center, and say this is what is the displacement, or this is the radius, and this length is E. Okay, so now, so probably I can call this as say a diameter, a vertical or diameter. Okay, there are so many diameters, such diameters I can draw. Okay, so there is a circle. What is this now? There is a circle whose radius is A. That's all, whatever I have. Now, what is this? This is what we call it. What is this? This is the circumference. Okay, now imagine that I have a particle. I have a car, and car itself is my particle, and I am sitting there. I just draw it. And it is horizontal. Right now, this time is 0. Time is 0. I set it and then I start moving along the circumference. I start moving along this circumference. You are going to move this, and this is how I move along the circumference. Okay. So when I am moving along the circumference, it is as good as I am rotating about this point. Okay. At what speed are you moving? So I am moving at an angular velocity of omega. Okay, I am moving at omega radians per second. Okay, at a constant velocity I am moving, constant angular velocity I am moving. Okay, after some time, say after t seconds, okay, so my t is very small, say 0.1 second, 0.15 second, something like that. After t seconds, you must have covered some displacement now. Okay, so you have covered some displacement in time t. So what is that theta? Theta is equal to omega into t. Velocity multiplied by time is the displacement, the same thing. Okay, so I am talking about the angular motion, therefore sometimes you may not be that comfortable, no problem, but the relationship remains same. Okay, theta divided by the time, that is nothing but the angular velocity. Okay, therefore theta is equal to omega into t, and so after t seconds, so probably you have covered a distance, angular displacement omega t, and say you are here. So if you are traveling in the car, you are here after t seconds. Okay, you are traveling in this way along the circumference at an angular velocity of omega. Now I shall find out what is the projection of this on this vertical line. Or in other words, how much is this distance? This is what is my x. Do you agree that this is same as this also? This distance is same as this. So this is nothing but, if I call this as, this is my A, this is A, and what is this distance? A sine of omega t. This is same as this x. Therefore, x is equal to A sine of omega t. What is x? X is the displacement. X is the displacement. Now let me come back. Okay, so imagine a particle traveling along the circumference of a circle of radius A at a constant angular velocity omega. Then the projection of the particle on the diameter, say inside bracket vertical. Okay, the projection of the particle on the vertical diameter indicates the displacement. Indicates the displacement. Then this motion, then whatever the displacement, this displacement, the motion of this, the projection of the particle which is moving like this, that is nothing but the particle at when it is here, its projection is here. When it comes here, then its projection is here. When it comes here, its projection is here. When it comes here, its projection is here. That means it is moving along this. It is having displacement like this. Then it starts coming, then it comes like this. And similarly for the next, then it goes like this and comes like this. So whatever is the projection of the particle which is moving like this, that motion is a simple harmonic motion. Okay, so then I describe x equal to a sine omega t. Okay, then how do I say that this displacement, the motion described by this displacement is a simple harmonic? How do you say? Okay, check it. So I find out what is x dot. What is x dot? It is velocity dx by dt. It is nothing but a into a is a constant. Sine omega t differentiation is nothing but omega cos of omega t. This is x dot. So in my definition of simple harmonic motion, there is no velocity. I want acceleration. I shall differentiate it once again. X double dot. X double dot is equal to 1a as it is, 1 omega as it is. Then differentiation of cos omega t. So minus omega into sine of omega t. So this is as well as minus a into omega square into sine of omega t. Or this I shall modify with minus omega square, I shall write it as it is a sine of omega t. What is a sine of omega t? That is nothing but x. So therefore x double dot is equal to minus omega square into x. This minus sign tells you that the acceleration is towards mean position. What is the mean position here? These are the two extreme positions. This is the mean position. So even if the particle is, the displacement is in this direction, the acceleration is this way. So wherever it may be, the displacement is always towards mean position. That is indicated by minus sign. What is this omega square? Omega square is a constant. So therefore, I have x double dot is directly proportional to x. And therefore, the motion x equal to a sine omega t is nothing but simple harmonic motion. So making use of this, if I define, consider a particle which is moving along the circumference of a circle at a constant angular velocity of omega, whose radius of the circle is a. Then projection of the particle on a vertical diameter indicates a simple harmonic motion. So this is another definition. Okay, then there is also another way of what is called as a vector representation of simple harmonic motion. So vector represent any simple harmonic motion. Say for example, x is equal to 5 sine of pi by 2 into t. So you have to, this is nothing but a, this is nothing but your omega into t. So how do you represent this? So you choose a point and draw a horizontal line. This is my reference line, or what is called as a t equal to 0. Then you choose some angle and draw a line. This line is very, very important. This is what we call it as the vector, this. What is the length of this line? The length of this line is nothing but this. This is 5. This we call it as amplitude. And what is this? This is pi by 2 into t. Okay? So this is what we call it as a vector. This is a vector which represents this simple harmonic motion. Okay? So any simple harmonic motion can be represented by means of a vector. Okay? So if I have another, so let me call it as say y, or say let me call it as x2. x2 is equal to 10 sine of pi by 2 into t minus 30 degrees. Please remember, this also has same frequency. This omega is called as frequency in simple harmonic motion. X is simple harmonic motion. A is amplitude. Omega is called as frequency. So similarly here, 5 amplitude, pi by 2 frequency. So 10 amplitude, pi by 2 frequency. The frequency of this, both of them are one and the same. The only difference is what is this minus 30 degrees. This minus 30 degrees is called as phase difference. Okay? So if I represent this, the second one also as a vector. So choose any point, draw a horizontal line. This is what is called as t equal to 0. And then go back here. Then what is pi by 2t? So measure this. This is your pi by 2 times t. This is the angle. The same thing, pi by 2t. But I don't want pi by 2t. I want pi by 2t minus 30. So measure 30 degrees this side and draw a line. So this is the vector. This is the vector. What is the length of this vector? That is equal to 10. So this is 10. And what is this angle? This angle is pi by 2t minus 30 degrees. Okay? Therefore, this also is a vector. This also is a vector. This represents this. This represents this. And if I draw both the diagrams in one only, and this is what is going to be your this thing. This is pi by 2 minus 30 degrees. And the angle between this and this is 30 degrees. We say that this simple harmonic motion leads to this simple harmonic motion by 30 degrees. And what is this 30 degrees? 30 degrees is the angle between the two simple harmonic motions which have been represented by vectors. And that angle is called as phase difference. What is phase difference? Phase difference is the angle between two simple harmonic motions which have been represented as vectors. Okay, whenever you represent two simple harmonic motions by vectors, please remember the two simple harmonic motions should have the same frequency. If they are having different frequencies, then you cannot compare them. Okay, then the angle between the two vectors is known as the phase difference. and probably this much is sufficient. And now, so with simple harmonic motion, etc., all these background terms, probably I can start something which is mentioned in your syllabus in my next lecture. Okay, all the best.